So for this week, we are going to be talking about hash tables. A hash table is basically a data structure that is intended for storing data that you want to be able to search for in a more efficient way. So if you think about storing data in an array, if you were, say, storing usernames and passwords and you just slotted whatever username password combination was to each index as it came along, you would have to search for the given username and password through each index every single time. Not a problem if you only have a couple hundred users, becomes a problem when you have a couple thousand users. So what a hash table does for you to help with this is it will take the information that's coming in, apply some sort of hashing algorithm, which basically means that it's going to perform some operation on the data that will, in the end, provide a positional number. And if possible, it will then store that data into that position of the table so that whenever that data is entered, it can go through that same hashing algorithm, tell where it needs to look. So the question then becomes, how do you know how to give that position to the hashing function? So there's a great many different types of hash functions. Some of them assign an integer key and turn it into an index. A lot of them use some sort of division method. So if you had the following numbers that you wanted to map to an array of 10 elements, you could apply a division method where you divide the number by 10, or the maximum number of elements in the array, and use the remainder as an index. So 1, 2, 3, 4, 5, 6 mod 10 would give you 6 as the index. 7 as the remainder would give you 7. 0 puts you to 0. So it would be stored like this. 1, 2, 3, 4, 5, 0 in the 0 spot. 1, 2, 3, 4, 5, 6 in the 6 spot. 1, 2, 3, 4, 6, 7 in the 7 spot. Of course, this only works if your keys are integers. So what do you do when the keys aren't integers? Well, then you have to apply some other type of hash function that turns them into integers. So you'll need a function that gets an integer, and then you need a function that makes some sort of use of that integer to figure out what key it needs to store in the array. So say you have some names, like Sarah Jones, Tony Baloney, and Tom Katz. Your goal is that when one of these names is entered, you need to get an index to access that information. So probably the easiest way is to just simply convert the string to an integer. There are usually string to integer functions in most programming languages. So if you had some sort of function that turns, say, Sarah Jones to 1038, Tony Baloney to 1259, Tom Katz to 746. Then you could just apply the same hash function we did above and get 8, 9, and 6, which would look like this. Now, the very obvious problem you might already be considering is what happens when two keys yield the same index. So if you wanted two people that had, say, the position 8, you're going to have a collision because there's already stuff there. And there's two methods of resolving this, and which one you use would depend on how you created your hash table. There's also more than just those two methods, but these are the two main ones that most books teach. The approach we're going to use in this lab is called chaining. Chaining sort of creates a linked list out of that index. So if you had multiple entries that wanted to use position 8, whatever was there first is placed, and there's potential for the linked list to point to whatever else would want to use that space that comes after. So it's called chaining because they kind of chain together. So hash tables are good in situations when you have a large database and you want to very quickly search and retrieve the information. So government records such as driver's licenses, compiler symbol tables, internet search engines, just large databases. and password user systems, things like that. Your typical operations for a hash table is to check if it's empty or full, as always, to insert an item into the hash table, remove items from the hash table. Biggest one here is retrieving items from the hash table. You can clear it, remove everything, and you can show its structure. So the application we're going to be looking at in this lab would be looking up passwords. So this is going to outline an algorithm that we're going to use in the exercise that you are going to finish later. So there would be two major parts. You're going to have a username password database. We're just going to have basically a text file called password.dat. And it would just have username password combinations like this. The program will present a login prompt. It's going to read the username you enter, present a password prompt, look up the information using the hash table, and either prevent or present authentication successful or authentication failure, which might look like this, where the login is Mary, the password is contrary. Since that matches, it's successful. If you tried Jim and contrary, it would fail, so on. So some more details about this. To convert from a string to an integer, we can add the ASCII value of each character together. So Mary's conversion might be 109 plus 97 plus 114 plus 121 would equal 441. And the function's going to look like this. Int hash, because you're returning an integer value. The string that you're bringing in, value starts at 0. And for each of the characters, value plus equal essentially what will be the integer value for that character. And then when it's all done, return that value. And that will convert your string to an integer, but then you'll still need to convert the integer to an index. You'll have an array of 10 elements, so mod it by 10. So you'll get your index by hashing the item, modding it by 10. 441 mod 10, for example, will give you 1.